This is a short, very short movie, how it's functioning. If I'm reaching this antenna, this green wire antenna that you're seeing here, if I'm reaching it, you can hear in this buzzer the sound. The sound is made by that 555. Here is a op-amp, that one, LM358. And this is a NOT gate, 7404. And this is the the effect. Actually, the LED is more responsive than the needle that I'm having there. But the needle, it is moving a tiny little bit, you see? It is trembling. And if I'm touching the antenna, it's the highest effect. It's catching it. I kind of tweaked the needle to be on the middle here, because usually it's on this side. If I'm powering it off, you see, that needle is there. And when I'm powering it on, it will jump to, you see, to the middle, relatively. See. Yeah, well, it's trying to jump sometimes a little bit too far, but usually it's on the middle there. And I calibrated it with 220 ohms here. This green, you cannot probably even see its color, this green resistor there. And here is the violet wire on the output of this NOT gate here. And the input is coming from the output of that op-amp and all that resistors there that are doing an interesting job. I had to put a diode there because the signal was affecting this other circuit, so it's basically only one way. It's not vice versa for the signal. And this is the 555. If I'm tweaking, well, I'm close to the antenna, that's why it's blipping right now. I can tweak the how fast, you see, from that potentiometer there, I can tweak how fast. Yeah, the needle is barely. The only problem that I'm having is this needle. I cannot make it jump all the travel. That's what I wish. I really wish to see it travel way more distance. And this is the best, literally the best amplification that I could do for this coil meter that I'm having here, that I repaired very recently. It was good for scrap, basically. And now it's working, but well, it's not properly amplified. That's why it's moving a tiny little bit. But it is working from 0 to 10 quite nicely, depending how much current I'm providing to it. And also I calibrated there with, I tweaked it with that resistor, because before I used something else, some other values, and it was somewhere there. Sometimes it was very close to the 0 and I didn't like it either. So I kind of tweaked everything until I find the middle point there. Well, relatively, because if I'm bumping it, it will jump a little bit, motherfucker. Yeah, it will go. But usually is jumping and remaining on that middle point. Let me reset it again, probably no. Yeah, and now I can bump it a little bit, like that. And it's relatively on the middle. And it's good enough, you know. I don't want it there. I want it when one beep is happening here. Actually, the camera is not catching all the flashings of the LED all the times because of the frame rate, probably. Sometimes it's catching the flashing of the LED. Yeah, he is lighting up all the time. For all the noises, all the clicks that you hear, this LED, it is in reality lighting up, but the camera is catching only a fraction of them. Not right now. Right now it is staying off. It's not lighting at all. But when I'm getting close to the antenna, it's starting to light on. So that's it. This is the circuit. I hope you like it. That's the 2N7002. And this is the buzzer that I connected it on its drain. From positive, the positive is coming through this buzzer and getting out into the drain, and then is going into the 555, because the 555 is staying on high, on 5 volts all the time, and only very small spikes towards 0 volts are happening. And when those spikes are happening, it is creating this beeps or clicks on the buzzer. That's the idea. So I had to play around till I find this interesting situation. And I'm collecting from the same pin, I'm collecting the signal and I'm transferring it. And I try to amplify it here with this mambo jumbo, but it is doing something at least. And sometimes I got even stronger moving there, stronger than that, probably because I have to put it to the maximum there. So you see, yeah, it's very shitty right now, very shitty. So right now when I'm literally touching the antenna, is moving a tiny little bit. Yeah, I wished from 0, not to put it on the middle like it is right now. I want it without anything there, without any resistor, to stay on 0 when nothing is happening, and when something is sensing, to move close to the maximum like that. That will be nice. But you know, I find a solution right now. At least the LED is very responsive, actually. Yeah, very responsive. Yeah, that's all the amplification I could do. All right, that's it. All right, and I played a little bit more with a sense of desperation, because I wasn't sure if it will even work, and I didn't know exactly what I want to obtain from this circuit. So It was like a play, but not a nice play, because I was very sure I failed with this circuit already. So this is a very good story for how well a break from everything can be. Do something else totally and then come back to the circuit and try to resync the strategy. My test that I came with was to find the exact cause of the, if you remember, the needle was staying in the middle here and it was moving a tiny little bit. And when I moved this wire, which you see, that's the positive here and this is the negative for this meter. And when I'm taking out this wire and I'm connecting it to negative, you see how it's going almost to the maximum. It is limited because of this resistor. That's why it's not going into the maximum for the moment, but it is moving very, very nice. So let me put it back here. When I made exactly this test, and I've seen it is actually doing the thing, and I was trying to understand from the circuit perspective how to make it move so much. Then I started to link this wire further in the circuit. It is already linked here on this NOT gate, then on the op-amp, on its output there only, and see what's happening on that MOSFET that I'm having there, and then directly on the signal from the 555. And I could see a very, very nice swing from the pulsing of the 555. So the needle was moving very, very nicely. Of course, if I was having a big enough capacitor, which is the same right now there, that is a 100 microfarads capacitor. Then I started to think, what the hell, how to make it swing like that, like it was directly put on the output of the 555. And then I realized, hopa, let me think about this MOSFET 2N7002 as a simple sensor that it needs to command something. So that's what I did here. This sensor is sending its signal. So this is the antenna, this green wire is antenna. This is the positive, is linked to the positive rail. And then on the drain and on the source, I'm actually having two connections. So I'm having this connection from the source pin there, with this resistor on the base of this NPN BC548. I know you can barely see it, but believe me. And another wire from the, so it's a junction. One signal is going there to this transistor, and another signal is going there into that 55 on pin 7 actually. But I'm having that wire that is going to pin 7. I had to resync a little bit this 555 circuit, a tiny little bit. I changed it to get a slower pulse than I was getting before. That I was having a too faster pulse before. So now I slow it down. That's what I did there with 1 kilo there between pin 6 and pin 7, and this 100 kilo. And you can see that a resistor is across this capacitor because it was beeping very, very annoying for a very long time. And it was that capacitor that was holding. And in the end, after a couple of good seconds, actually, it was stopping. And you see right now it's still having a little bit of, you see? Yeah, that beep at the end, and then it's coming back. That beep at the end is actually, it's staying like that because of that capacitor and because of that very large value, 10 kilo I put there. I put 1 kilo there, but I'm not getting the same nice effect like I'm getting right now. So with that 10 kilo is actually letting me having a nice effect. That's the trick. That's why I use that 10 kilo there. It's a bleeding resistor for the capacitor. That's the entire purpose of that resistor. And then the signal is from the output of the 555. Pin 3 is going into the collector of this NPN. When it's sensing the signal, is activated through that 1 kilo resistor and is sending the output of that 555 to its emitter into this op-amp here, which is in buffer mode right now. It's like a tiny buffer, but it's more than a buffer in the same time. Well, I'm thinking about it because this is actually an amplifier, this transistor, and this is a double amplifier. So this and this should be I'm thinking for the next circuit. That's why I'm making this movie while I'm having this working circuit here. So these two guys should become one single component, either or a single transistor. And I'm thinking for the next update for this circuit, how can I simplify it a little bit more than it is right now. And then the signal is going there into that op-amp, and from that op-amp through this wire is going into the NOT gate. And I changed this position from this buzzer. It was directly on the sensor, but I leave the sensor alone to do its job. And actually, the same function that I'm getting it here, I can collect the buzzing here on the emitter of this NPN, but it's having a little bit of strange noise. So this is how it's functioning. You see, this is how it's functioning right now. The thing is, let me explain a little bit what is happening here, because I really didn't understood what the hell do I want to make with this. So right now, my body is catching 50 hertz from the mains, is vibrating. I am vibrating at 50 hertz. To prove it, let me bend this antenna towards here to be close enough and to be able to touch my iron table that I'm having here. So like that. So if I'm close to it, very close to it, it's sensing. Okay. If I'm touching it like that, is also sensing. Also, this needle is moving quite a bit. You see? Yeah. So pay attention on the needle, but also the LED is telling you everything, and also the buzzer. So when I'm touching my table, when I'm getting close to this green wire, I know you cannot hear or see anything, but you see, even if I'm grounded, sometimes I'm not sure exactly, but is diminishing seriously. Is diminishing when I'm grounded. Is diminishing the sensing attributes of that. You see, back I'm touching. I'm literally touching it and nothing. And if I'm not grounded, you see, it's buzzing like. So this is what is happening. It's sensing my 50 hertz from the mains, and because this is not a fast frequency, but it is fast enough for this moving needle and also for that LED. So pay attention a little bit what is happening here. So when I'm very far away from the wire, is like 2 hertz, and as much as I'm getting close to it, to the wire, you see how he's increasing the frequency. And as closer and closer and closer and closer and closer, you see it's very, 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 very high. As long as the frequency is increasing, this needle, instead of staying here, is going down, 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 down towards zero. As long as the frequency is higher and higher and higher, this needle is going down, down, down. So pay attention. So now when it's small frequency, like 2 hertz or 10 hertz right now, it's staying there in the middle, you see? And it's beating there. And as the frequency is increasing and I'm getting very, very close, you see? I can do that. And this is the behavior of the circuit. That's what I was trying to really to understand how to model everything. I was working with multiple variables here, and I didn't understood them 100%. But I kind of worked with this sensor, with this MOSFET before as a sensor, and something remained in my mind, and it wasn't easy to make it work as you are seeing it right now, and to understand what is going on. Yeah, practically this is it. This is the functional circuit that probably I wanted it in the very beginning. I didn't know what I wanted. I wanted something, something to move here more and to sense and to react to my hand here and to beep and to create a lot of noise or beeps. Let me show you this buzzer if I'm moving it there. Yeah, you see? It's creating like a meow. Meow. It's an interesting effect. It's doing exactly the same thing as before, as here. You see? But it's adding this meow at the end, which is interesting. Interesting. It's probably because this is a capacitor, and its capacitance is playing a little bit of a role with that transistor there. Is interfering somehow. But here is more on and off, more binary, you know, is logic, and is not really affecting the circuit. But here in that position it's on the emitter of that transistor when I'm mounting it, with positive here, negative here, is on negative there. So that's meow, meow. Let me put it back to its position here. I'm using 2 gates from this chip, 1 gate there, the first one, and then the output on the input of the second gate, and the output of the second gate is driving this buzzer. It's the same as on the transistor, positive here, negative there. It's probably is having a tiny little bit of tendency to meow a little bit, but it's more because of that resistor. If I'm changing the resistor, it will not meow like this. It's having like a tiny delay at the end. Yeah, I managed to make it move more than it was moving before. I did try to change that resistor to something less than that value, 200 ohms, to make it move to the entire travel, and it didn't work. It didn't like it at all. So that resistor is somehow dependent on the circuit. I calibrated everything with that resistor there. It's very, very strange. That's a very important resistor there, very important. And also through this LED is driven extremely hard, this LED. A normal LED will be burned at this voltage that I'm having here, and with that tiny resistor value there. But it's a very good LED what I'm having there, very good quality, and from AliExpress, from China. Yeah, it's a very weird and strange circuit, very strange, but it's doing what I wanted, kind of. All right, is moving the needle there. All right, this is a kind of a frequency sensor. This antenna is sensing the frequency quite seriously. It's a strange circuit. Yeah, I want to simplify it a little bit more, and after I'm simplifying it, I will put it on a cardboard, and I will make its own circuit, standalone and mobile, not on breadboard like it is right now. Also, I tried a lot of permutations. You have no idea how many things I tried, as you can see, and that's only a fraction of what I tried here. And yeah, it's working. That's what is important. It is working. All right. And voila, I changed a little bit the circuit. I took out this op-amp, and it was very good that I noted down the circuit before, because I wrongfully believed I was having that capacitor on this pin 6 while it was actually on pin 7. And that threw me off when I tried exactly this version that you are seeing right now, and it didn't work. And I was scratching my head why it was not working. And then I put back the op-amp there, and I checked my circuit that I copied down on my computer, and I was having 100 microfarads, and I tested a bunch of capacitors, a bunch of values, and the nicest that I could find, well, the effect is with the 220 microfarads instead of that 100 microfarads. It's a trade-off. Some bunch of the effect is nice, but some other bunch is not that nice, but it's good enough. Let's see how it's behaving right now. So the needle is on the middle there, and when I'm closing to the antenna, you see how large the movement is right now. And you see? So it's going down to 0. And this is very nice, but if I'm doing this, you see? It's becoming a very strident and very annoying beep at the very end here. He doesn't know what to do. The frequency is decreasing very quickly, very high. It's transforming into a scream, a very annoying noise. Like a beep. And yeah, I don't like that, but that part. But this part, I love it. This part where it's blipping. This is very good. This is very, very, very close to what I envisioned, what I imagined at the very beginning when I started all this project. Basically, I wanted this coil meter that I repaired, because it was for scrap, for scrap. Inside, it was blown up, a lot of pieces, and I rebuilt it back how it was originally, relatively. This is what I really wanted. Well, I wanted a project for it, doesn't matter what. When I'm putting my elbow on this vise, I'm grounding myself through this material, and you see, if I'm getting close to it, it doesn't work. Like I told you before, you see, if I'm touching it, it's actually responding. But if I'm getting very, very, very close, it should work, and it doesn't. And it's cutting all the frequency that is inside my body. But the moment I'm getting out of grounding, is functioning fine. It's sensing correctly everything. So that's why, you see, when I'm doing this, I'm grounding myself. I'm not moving this hand. I'm just keeping it. I'm moving only this arm with the phone on it. So that's the original idea that I had, to repair this coil meter and to use it in what doesn't matter, whatever project, whatever. And then, like I said, I asked in the forums, and really nobody gave me any good idea about it, and which is pretty elementary circuit you should make with this kind of coil meters. I don't think it's such a big deal, and pretty desperate, I may add, because I had a ton of bad behavior, and even this circuit that I'm having it here, that I managed to simplify it a little bit there, it's still a little bit mambo jumbo here in this side. I don't really understand what is going on with this resistor and this LED on that pin there. And it's a combo, it's a combination here that is a bit very dubious, very dubious. And I don't completely understand it. There is something. If I'm changing one parameter in this area, here is blowing to pieces, is just not working correctly. But I managed to change that capacitor, and it's very good. You see, you notice right now it's not stopping like it was stopping last time. You see, it's very responsive right now. If you remember, it was at the end when I was retracting my hand, it was remaining and then stopping, like creating a little beep or meow and then going back. It is kind of creating a little bit of meow here, but it's a lot more different than it was before. So I have to reverse like this. So now I inserted it there, and it's not working. I put it wrongly. Okay. Yeah, you see the meow. You see how this is influencing the entire circuit here, is keeping that needle on the middle, while when I'm moving it there, the needle is coming back and the LED is opening. You see, it's a bit different. It's still interesting, but nah. 9. I like it better here. This is way more better. Not that. Hey, motherfucker. No. Like that. No. It matters how you put it. It matters very much, actually. So that's why in experimentation you have to move everything around until you die, until you find the proper way. So now it's functioning fine. It's functioning okay. And it's nicer with that capacitor right now. That's what I'm saying, and it's a bit less components at this point. And I did took out one gate, and I connected everything on only one single gate there. But this secondary gate is playing an important role. It's cleaning, is adding a little bit of clean output behavior especially for this buzzer. It was creating a continuous, very high pitch noise when it was only on one single gate. But here on this secondary gate is just silent. Maybe that high pitch is still high, but I cannot hear it anymore. And now it's perfect. Now it's good. It's totally fine. And the travel is very nice. That's why I'm saying this is very, very close to what I originally envisioned. But it's a bit tricky. The distance is not that great here, and it's a bit tricky to use it, you know, to use it to have a good output every time. You know, you can get into this annoying beeping very quickly, but if you are careful, you can get a very, very nice effect. Very nice effect. This is good, and the travel is very good. The travel of the needle is going back there, very, very nice. And the sound and the LED that is accompanying this movement is is adding to the cake, is adding flavor. You know, it's an interesting device. All right, that's it. I hope you like it. All right, hello for another update. I made a tiny little bit of modification, but it was important. Well, relatively important, and it actually gave me better results than with the previous setup that I had. Remember, I was having this LED that I literally abused it by putting this 200 ohms on it, and it was literally pretty much on the supply line on that 5 volts with a very tiny little bit of current limitation protection, and it was super hard driven with only this 200 ohms resistor and through this coil that I don't know if it's probably less than 1 ohm resistance. I didn't burn it because these are extremely good LEDs that I stumbled upon them by chance, and they are new LEDs, new from I don't know, 2019, 2018, like that, when I bought them, and probably 1 or 2 years before they were produced. They have you can see that yellow tint inside them. They have phosphor on them, and they are super bright and super low current, super low current in order of microamps. And it's lighting up very dimly, but it is lighting up, and they are fantastic, good, very, very extremely good. They can be lit without any resistance on the 5 volt supply directly, without any resistance, just plug it in. But it's super hard driving like that for them, and I don't like it. They do provide an extremely good illumination, but it's best not to do it like that. They are not for illumination; they are for signaling in the circuit to signal to me something, that something is on and something is off, pretty much. You know, and what I did, if you remember from my last video, I had this wire. So this was continuation with that LED, with this LED into the ground, and this wire was between the leg of the LED and this resistor, like it is here. And by simply putting this wire directly on the resistor and directly on the signal that is coming there, and this is plugged into the positive, so there is the negative on the first NOT gate of this chip. Let's see how it's working actually. And it's a bit more sensitive, I believe, not having the LED on the wire. It was cutting the sensitivity of this coil meter. And right now, at least the distance is a bit more larger, you see? So I kind of increased, I believe, I'm not completely sure. Probably the atmosphere in my room changed because it's more colder right now. Probably it affected everything. A tiny little bit of tweaking here, it is affecting what is going on there in the sensor side. And look at the needle, how much travel is doing. And closer I'm getting to it, is getting to the 0 point. And this is the annoying part at the end when I'm very close or touching the wire. So if you're not touching the wire or getting too close to it, it's creating a very, very, very nice beeping sound. Very nice, very cool. I really like it. And this is actually the effect that I was envisioning in the very beginning. Again, the intention for this circuit, I only wanted a nice circuit specifically for this repaired coil meter that you are seeing here. I repaired it and I wanted a project for it because I'm having it literally for years laying around in my box, doing nothing, and I wanted just anything, any kind of project, doesn't matter what. And I asked this question on an electronic forum, and the guys there, they were mute. They didn't give me any kind of response, Only one guy with a half a mouth, he said something about measuring the current and display it on this meter. It didn't solve its idea too well, and I remained on this circuit diagram specifically made for this repaired again coil meter. Okay, now the LED situation. As you can see, if I'm getting close to it, the LED is lighting up, but now is way more dimly than before because it's using a bigger value resistor there. Let me show it to you. Usually I'm using 10 kilo or 1 kilo for LEDs, and this one is having 5.6 kilo. This is the order you are reading it. Green 5, blue 6, red is the kilo, and the golden band that is not visible anymore. And that's it. This is how I tweaked my LED, and the band leg is the positive and the resistor leg is the negative. So it's very easy to remember and to distance the legs, this is my test LED. It is also a very abused LED that I use it everywhere and it's still working fine. Just don't put it at 240 volts there and it's okay. So the LED, where to mount it in this circuit, and actually it's not really a big problem. You can mount it pretty much everywhere. Well, in a couple of places, at least 2 places I found. The output of the first gate and the input of the second gate, where this link is. So I'm putting it with the positive on the gate and the negative on the rail to remain off like that. And when I'm getting close to the antenna here, is lighting up by the bips. Exactly, perfectly the same situation as it was before when it was linked to this wire. So it's really not a problem for the LED. And the second place, I find it here directly on the signal line on this amplifier transistor. The same thing, positive and negative. But here is a bit less strong for some reason. And because it's getting the signal directly from the 555, that's why. Here is a bit more better amplified, is buffered, that's why is better luminosity and stronger current. And the third place is directly on the 555 pin output. Well, that's the wrong position because it's staying lit all the time. Let's switch it. So I'm putting the leg on positive, as you can see, and the negative on the pin terminal, and when I'm getting close to it, you see. So it doesn't matter, and it's having a better luminosity directly on the output there as well, and is not perturbing the. So let's see if it's perturbing the functionality. It's not. It is not. You see, the needle is moving fine as before, no problem, and the LED is strong and good. But I prefer it here at the end, where everything else, all these displays are connected. I'm calling them display. This is a needle display, audio display, or warning, audio warning or display, and this is a LED display, and that's it. Very good luminosity. You can tweak the luminosity from that resistor that is having there. Put less resistance towards 1 kilo or even less if you want. If you want to really abuse the luminosity on that LED, but for me it's good enough as it is with this 5.6 kilo. And yeah, that's it. This is the update for the tweaking of the LED position and where you can put it in the circuit, and a slight and better movement range of the needle. It's kind of finished at this point. Right now I can transplant everything I'm having here into a cardboard board that it will take me a couple of hours to make it, to put the pads, and probably and my intention is to film it, and also in the same time I will show the circuit diagram finally. Okay, this was a lot of testings, and that's why I didn't show any diagram. Yeah, that's it. See you later when I will actually build the circuit and mount it on this coil element. All right, I have 2 options. So I have 2 options for the NOT gate chips. I can use this 7414 longer pin chips with 6 gates inside, or which is this. I prepared it here. This one is exactly the same thing, only the case is different. This one single gate chip that is this tiny and it's having 5 pins, and I can use 2 of these because I only need 2, like that. I can use this 2 because I only need these 2 gates there, and these are too tiny and the pins are way too small, and I'm opting for this because these are small but not that small, and the chip itself is acceptable. I do like this kind of spacing for this pinout, so probably I will use this one. And the problem is that in my circuit that I tested it, which I'm having it here on the side, I'm not dismantling it because while I will build the actual circuit, I will probably have to test with this other one to see what problems I will have on the board circuit, if they will come, if they will appear. You sometimes, while you are making the circuit board, along the way you kind of get some problems, stupid problems mostly, like a wire not connected where you should have, or stuff like that, or even damaged components, because I am using scrapped components. These are new. This 7414 are brand new, but other components like capacitors, resistors, probably this transistor here, they will be, and also the LED, they will be repurposed. Getting back to the idea that originally I use this 7404, and what I'm using right now is this 74104. This is the circuit, by the way. The thing is, this is Schmitt trigger and this is not a Schmitt trigger. It is just simple. So I have to test it here to see if I'm getting the same effect as before when I was using this non-Schmitt trigger. And this is my batch of 7404, not Schmitt trigger. And if you want to see my box of integrated circuits, and I have to find a 7414. I think is this one. Yeah. All right. Let's see this one. 74 14. So let me swap this with this one and put it correctly. The pinout is exactly the same for both, so that's no problem swapping between them. It's the same positive, negative, and the same gate position, so it's really okay. I hope it will not be a problem, but it's better to test now than to be sorry later. And of course, it's doing some funny business here. Huh. It is working, but is reversed. Is reversed. What I think I must do, damn it, or to use this 7404 that I used originally. Let's see. I think I can modify it because it is giving signs that is working, and I should be able to link another gate. So let's see, like this. So the output, I'm having 3 gates here. Another gate. Shit. It will mess up my diagram here if I'm tweaking. Let's see if I can. Yeah, the needle is moving, good. But this beeper is not sounding because I put it wrongfully. I'm an idiot. I am an idiot. This one I should put it inverse and work. So if it's not working in one way, it will work. No, it's not. Motherfucker. Okay. Then let me add this. I'm polar. There. Positive. No. Yeah. Shit. So do not use Schmitt trigger for this circuit. It is kind of working, but the beeper, at least the beeper is the problem. Damn it. So probably I will have to use this simple 7404. It's not staying, it's not remaining, it's moving down. That's the problem. Let's see if I'm swapping them, if it's the same problem. And it is not the same problem. The thing is that I can see it on my dial here. The needle after using this one is staying a little bit on the middle here, but then is slowly going down, and then the beeper is beeping up. When it's going down, it's beeping, and the LED is lighting up. And when it's here in the center, everything is off, including the buzzer and the LED. You see? And when it's going down there, you see? And this is what is happening with this one. It's going by itself down. Probably I should make a special version for this 7414, and I bet it will be an easy trick to do, but at the moment I don't know how to do it, and I already made this circuit diagram. So that's why it's better to test first and then use the SMD components that you have. So this is a problem. Yeah, it will go down. That's the problem. Slowly but surely. Yeah, you see? Probably if I'm inclining it. Yeah, you cannot see it, but the needle is here, and that's why. You see, it's remaining a little bit there and then going down. That's shitty. Let's see if I can somehow, tweak it. I will add this to not bother me. So let's see if I can tweak this little thing here. Hopefully I can make it work and not fuck up the rest of the circuit. Very, very shitty. Very shitty. No. Interesting, very interesting. Check this out. And it's resetting on the middle here. And it's actually creating a little bit of clicks, which is nice. Yeah, you see, it's going back, it's trying to get back to the middle. That's good. This is a good trick here. So what did I I put on the second gate here a capacitor, and it's here 100 nanofarads. I am very lucky with this thing that is working right now. Very good, excellent actually. And I like the little cracks that is doing, exactly like a Geiger effect almost. Those are super cool. Yeah, can you see the needle? Hopefully. And I believe it's the same sensitivity as it was before. I don't think it changed. You have to be careful how close you can get to the antenna. The good thing is that it's coming back. That's very good thing. So this is what I did. I put 100 nanofarads there. So let me check it again. Input, output, input, output. Yeah. Yes, exactly. On the leg of this guy. And this is coming from positive here to the negative on the pin there. Yeah, it's good. It's good. So that's it. Very small, very small update on the fly. So now, theoretically, I can use this Schmidt trigger, not gates. This 7414 is a little bit different from this. I know for sure. They are better actually, and I have a lot of them. So practically what this is doing here is probably in parallel with that guy, because here is receiving positive and this one is receiving positive on the other side, and in the middle here is the negative. So that's why I think it's in parallel with that. And two capacitors in parallel is increasing the capacitance, right? So I made a bigger capacitor. And being a capacitor, I don't know, it's holding the charge. It's holding the charge here on this point, here on this point, when it's positive. I don't know. I really don't know what is going on there. But this is an unexpected behavior and a pretty good one actually. Excellent. This is excellent actually. Yeah, I was very worried for a moment, but now it's working fine. Excellent. Good. All right. So this 04, I can put it back. So 7404. Okay, good enough, yes. And if it will crap itself and it will not work with this chip, I'm screwed. Well, I will risk it for a biscuit. Yeah, very nice cracking. I really like those cracking sounds. Very cool. I want to understand when it's crackling to enhance the cracking a little bit more. Let's see if I'm putting... yeah, here it is. Another one in parallel with that. This is 100. So this is again with 100. And it's coming back, good, because it's a different type of capacitor, a little bit than that one. And this one, if I'm having space there, I don't see to have space. Shit. To put this in parallel, let's well, I will use going back. Okay, I will use another. I will use from here at 200. You know what? I can put a 1 microfarad. Let's see. It's not cracking, or it made one crack, but this capacitor, it is helping a lot. Yeah, one microfarad is too much. I was thinking on it. It will be. So let's see. Now it's kind of stuck here, but if I'm activating it, it will go down. Yeah, this is 4 nanofarads. What I'm having here. Interesting. So if the value is too low of the capacitor, if it's 1 nanofarad, it's going down as before. Very interesting. I will use 22 nanofarads. And it's going back. Interesting. It's taking longer to get back, but it is getting back. And I increased the number of I increased the number of cracks. It's cracking a little bit more. Yeah, let me put you very close to it to actually hear it, hopefully. Very nice, very nice effect. Good, excellent. That's interesting. So here, let me update this one between 10 and 100 nanofarads. Actually, this was 22. Let's see actually with the 10. Come on, maybe. Yes. Okay, it's good with 10 nanofarads also. And it's getting a lot longer, no? It's kind of getting stuck there. It's kind of getting stuck, but it is coming back. It is coming back. But it's not creating those nice crackings as before. So let's see with 47. 3. 333. Okay, this is a little bit more higher. It's not much, but I cannot find it very quickly right now. No cracking? Yeah, nice. Okay. It's doing it by itself, this last part, which is okay. Yes, it's okay. Okay, okay. Let's say again with 100. Yeah, it's not getting down too much and then cracking. It's okay with 100 probably, or a little bit less than 100. Lesson learned. So here is not actually from 10, it's better from 20. Okay, so this is the updated circuit, and this is how you test it, and this is how you repair it. With 100 nanofarads is more stable. Although it's not making so many cracking noises, but the needle was going by itself down and then up and making cracking with less than 100. So with that 22 that I used. So that's it for this part. Next, I will start actually building it. I was very concerned about changing this chip because I know there are differences, but there are not that many differences. But there are some differences, and you must be aware of them. All right, that's it for this part. All right, thank you very much, and see you later.